audio now. Okay, so we're going to solve this with the completing the square. So factor greatest common factor, there are none. Now what? To complete the square, what was that very first step? What had to be true? A is 1, right? So in this case, is the leading coefficient, even though I know it's a letter, is the leading coefficient 1? That's a 1? No, it's not. What is it? It's an A. How do I make that A a 1? How did I make the 9 a 1 yesterday? I divided by 9, because 9 divided by 9 is, what's A divided by A? Y'all with that? Okay, so I need to make my leading coefficient a 1, so I will divide every single term by A. Oh, with boxes. Lovely. All right, I now have x squared plus b over a x, y'all okay with that? Plus c over a, and 0 divided by a would be 0. Okay. All right, so step 1 of completing the square is make sure that a is 1. What was the second thing we did? Subtract c. We had to get rid of that constant, right? Because we're completing the square on that ax squared, or that x squared plus bx. So I've got to get rid of the c. What is my c term right now? C over a is my c term. I'm going to subtract c over a from both sides. So on the left side, I have x squared plus b over a x. Remember to leave some space, because this is where I'm going to complete the square, equals, subtracting c over a from both sides gives me a negative c over a. Good with that? Okay. The next part of completing the square is finding that value. Remember, to complete the square, you have to add something. I need to find that specific value that I'm going to add to both sides to make this a perfect square. What was the process there? Okay, yeah. First thing I did was identify what b was, right? Okay. And remember, b is that second coefficient. This might be a little confusing because I'm going to say b is equal to b. Well, that's kind of weird. Okay, b represents that second coefficient. What is currently my second coefficient? B over a. And then what did I do? Took half of that, right? What is half of b over a? If I multiply b over a by 1/2, I'm multiplying a fraction times a fraction. You just go straight across, right? My numerator would be b, and my denominator is 2a. Okay? Ugh. Close enough. Okay. Now that I got half of b, what did I do to half of b? Squared it. Okay, so half of b squared. Square the numerator. Square the denominator. 4a squared, yes? Okay. How are we doing, guys? Be honest with me. Barely hanging on? Okay. This is messy. I'm not going to lie. Okay. To complete the square, what do I have to add to both sides? I add the perfect square. I will add that to both sides. Good. The left side is a perfect square. The left side factors. I guarantee it factors because we made it a perfect square. It will factor into, and this is always the same when you complete the square, it's going to factor into whatever the square root of this guy is. So the square root of x squared is x. And what's going to go with that x? Whatever half of b is. In this case, half of b is positive, right? So I'm going to put plus b over 2a squared equals. Okay, we actually have to add the side. Can you add those like they are? Okay, what has to be true to add fractions? Denominator has to be the same, right? Are the denominators the same? No. So what would be the least common denominator? Almost 4a squared, right? So somehow I need to make this first denominator a 4a squared. So how do I make an a turn into a 4a squared? Multiply it by 4a. But if I multiply the bottom by 4a, because I'm just multiplying by 1, right? So if I took that guy and I multiplied it by 4a over 4a, that would give me the top. I have c times 4a, 4ac, and the bottom I would have 4a squared. Now I'm going to write this plus b squared over 4a squared. Can I add those now? So I'm going to go and go to my next step. Left side, I'm just going to leave it alone because I'm not doing anything with it right now. Okay, so when you add fractions, if the denominator is the same, you just keep the numerator. Correct? Combine the numerators. Can you see that my numerator is b squared minus 4ac? B squared minus 4ac all over what? 4a squared. Questions on that? Okay. Back to completing the square. The right side is now simplified. The left side is a perfect square. What can I do now? I need to get, remember, we're getting x by itself. Square root both sides, right? Okay. So I'm going to take the square root of the left side, and I'm going to take the square root of the right side. What is the square root of the left side going to leave us? What's the square root of that mess? First of all, remember we're solving for x, so there has to be two answers. Right? So because there's two answers, what are we going to write down? Plus or minus. Remember, a square root of a fraction, you take the square root of the numerator and the square root of the denominator separately. Can you do anything with the top? What is the square root of b squared minus 4ac? Are there any perfect squares there? Well, b squared is, but is b squared minus 4ac a perfect square? No. So the square root of b squared minus 4ac is the square root of b squared minus 4ac. Is this looking familiar? Look at the denominator. What is the square root of 4a squared? 2 all over 2a. Interesting. Next step. Okay. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Can I combine that? That's two fractions with the exact same denominator. So I can write the top of it together with one denominator. So I get x equals, numerator is negative b plus or minus the square root of b squared minus 4ac all over 2a, and this is called what? That's called the quadratic formula. Okay. So the quadratic formula was derived. The quadratic formula, someone just didn't sit down one day and go, I think if we had a quadratic, then the answer is x is equal to negative b plus or minus the square. That's not what happened. They actually sat down and did what we just did. All right? If you understand this, if you're comfortable with this, you're so far ahead of the game. Okay, lots of stuff going on. We won't do this again. Okay? Know this formula, though, or have it on your cheat sheet. All right, so here's the quadratic formula. Obviously, a can't be 0 for multiple reasons. One reason, you can't divide by 0. Another reason, if a was 0, you don't even have a quadratic because the ax squared would be gone. Okay, so nothing really additional you need to write down from this slide here. Okay, moving on. Use the quadratic formula. This problem is going to have real solutions. We're going to use the quadratic formula to solve this problem. X squared plus 4x equals negative 2. What type of quadratics can you use the quadratic formula on? All of them. The quadratic formula always works to solve for x. Factoring doesn't always work. Completing the square always works. Well, that kind of makes sense that completing the square always works because we use completing the square to get the quadratic formula. Okay? All right, what would you do first to this equation to use the quadratic formula? Add 2 to both sides. X squared plus 4x plus 2 equals 0. To use the quadratic formula, we have to identify our a, b, and c. A is? No. 1. B is 4. C is 2. A, B, and C are the coefficients. Okay? So we have the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Do y'all remember what b squared minus 4ac is called? Okay. It's the very last thing we'll talk about in this section. I'm going to throw it in right now, so when we get to it, I'll fly through it. That's called the discriminant. We'll talk more about it here in a little bit, but the discriminant is going to tell you what type of and how many answers you're going to have, okay? When evaluating the quadratic formula, personally, I don't like to plug in A, B, and C and solve the whole thing at once. My personal preference is to solve the discriminant first, and then plug it in, and then solve from there. You do what you want, okay? Solving for the discriminant. B is 4 squared minus 4 times A, which is 1, times C, which is 2. So here we have what? 16 minus 8? 8. My discriminant is 8. Back to the quadratic formula. X is equal to negative B, which is 4, plus or minus the square root of the discriminant, which is 8, over 2 times A, which is 1. I'm just plugging stuff in. Am I going too fast, guys? Okay. You will pipe up if I'm too fast, yes? Somebody will say slow down? Okay. X equals negative 4 plus or minus, square root of 8. Does it simplify? Are there any perfect squares that go into 8? 8's not a perfect square, but are there any perfect squares that go into 8? 4. So I'm going to write off to the side, the square root of 8 is equal to the square root of 4 times 2. And the square root of 4 is 2, and the square root of 2 is the square root of 2. Okay. I don't have to worry about the plus or minus because it's kind of part of the formula. So negative 4 plus or minus 2 square root of 2 all over 2. Okay. If you enter that as your answer, it's going to be wrong because it reduces. Can you factor anything out of the top? 2. I'm going to go ahead and write the step down. If I factored a 2 out of the top, I would have 2 times negative 2 plus or minus the square root of 2 over 2. And because I factored that 2 out, the 2's cancel. So my final answer is x equals negative 2 plus or minus square root of 2. Questions, thoughts, comments, ahas? Okay. Here's another one. We're going to end up with a non-real or complex solution here. If the answer is non-real or complex, what's that tell you about the answer? Imaginary. It's got eyes in it. Okay. Step 1, set it to 0. So I will subtract x from both sides. I will add 4 to both sides. 2x squared minus x plus 4 equals 0. It's now in standard form. A is, B is, negative 1, C is 4. Quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is b squared minus 4ac. Plug our values in. B is -1 in parentheses squared minus 4 times a, which is 2, times c, which is 4. And what do you get for your discriminant? -31. Okay. Go back to the quadratic formula. X is equal to, I've said this before, I'll say it again, I bet I say it again at least one time in the future. Do not forget parentheses when you're plugging numbers in. Don't fall into the trap that says, well, the quadratic formula says -b, so that's going to be a -1 at the beginning. Because no, it's not. It's negative. Now I'm going to plug in b. b is -1 plus or minus the square root of -31 all over 2 times 2. -1 is 1 plus or minus. Okay. Yeah, 31's a prime number, so there's no perfect squares that goes into 31, but the square root of -1 is I. Okay. So I can take an I out of that, so I have I root 31 over 4. And I think my labs will accept that as the answer. Okay, I don't like it. I would want it in complex form myself, standard form. Okay, so it accepts that answer. I would break it up into the, remember a plus bi is a complex number? I would break it up into 1/4 plus or minus the square root of 31 over 4 I. Really? Okay, so sometimes it specifies in standard form. Okay. Okay, that's what it's saying. So this is standard form. Huh? They're both complex. They're both complex numbers, but this is just writing it in standard form, where you have your A, your real part, separated from your B, your imaginary part. Any other questions on this guy? Okay. Solve x cubed plus 8 equals 0 using factoring and the quadratic formula. What does x cubed plus 8 look like to you? Okay, headache. Look at x cubed. Look at 8. They're both perfect cubes. So we're adding, so this is a sum of cubes. So a sum of cubes, we can use our formula to factor this, right? And when factoring, we do one step and we're done. With solving wants to know what is the value of x. So with solving, we have to go a step further. So we start off with x cubed plus 8 equals 0. To factor that, what we have is we have our x cubed plus 2 cubed, right? And I'm not going to go through the whole process of this. You have your equation on how to solve this, or you've got it memorized, hopefully memorized. But x cubed plus 8 will factor into x plus 2 times the first guy squared, so x squared, opposite sign minus 2 times x, always plus the last guy squared, 4. So this is factored completely. But we're not just factoring, we're solving. I currently have 2 factors. So at this point, I can say, well, if this x plus 2 times x squared minus 2x plus 4 is equal to 0, then x plus 2 equals 0. This is that 0 factor property, right? So either x plus 2 equals 0 or x squared minus 2x plus 4 equals 0. And we solve this. Well, the first one's super simple. Subtract 2 from both sides, and I know that x is equal to negative 2. The other side, however, does not factor. That's just how it is. But we can solve it now because we have the quadratic formula. So we're going to use the quadratic formula on this. Remember, though, how many answers am I going to have? When I get done, I'm going to have 3 answers because this is a third-degree polynomial. One of my answers is negative 2. So don't get to this part here, use the quadratic formula, get 2 answers, and say, hey, those 2 answers, that's it. No, because this negative 2 is one of the 3 answers. Okay? All right, quadratic formula. We're going to use A is 1, B is negative 2. Come on, right. Negative 2, and C is 4. Okay. X equals negative B plus or minus the square root of b squared minus 4ac over 2a. I'll go off to the side and evaluate my discriminant, which is b squared minus 4ac. b is negative 2 squared minus 4 times a, which is 1, times c, which is 4. And you get negative 12. Okay. Go back to the quadratic formula. X equals negative, b is negative 2, plus or minus the square root of negative 12 divided by 2 times 1. Let's go ahead and take care of the square root of negative 12. Square root of negative 12 is equal to the square root of, first of all, there's a negative 1 there. Are there any perfect squares that go into 12? 4? 4 goes into 12. 4 is a perfect square. So 12 can be rewritten as 4 times 3. The square root of 4 is 2. The square root of negative 1 is I. And the square root of 3 is square root of 3. All right. Come back over to the quadratic. I've got x equals negative 2 would be a 2, plus or minus 2i root 3 all over 2. Factor 2 out of the top. Cancel the 2's. I get x equals 1 plus or minus I root 3. Is that in standard form? It is. If you wanted to be really, really picky, it's not quite a BI, but a lot of times it's better to write the I first because sometimes you might think that I is still inside the radical, and it's not. As soon as you took the square root of -1, that I came out of the radical. So my personal preference to write it would be the I in front of it. Now, if you have a fraction, write the I at the end because you have a set numerator and denominator, and I is off, not in the fraction. Does that make sense? Answer. Is that 3 answers? Okay. Questions, thoughts, inputs? Okay. Solving for a quadratic variable in a formula. Solve each equation for the specified variable. Use plus or minus when taking square roots. Letter A. A is equal to pi d squared divided by 4. Solve for d. What would you do first to get d by itself? And play the Jeopardy theme. Okay, yeah, clear the fractions, right? Get rid of fractions. Start off. That's a great start. Multiplying both sides by 4, I get 4a equals pi d squared. I'm solving for d. What do I do? No, I got to get rid of the stuff that's with the d. Divide by pi. Divide both sides by pi. Dividing both sides by pi, I get 4a over pi equals d squared. One more step. Take the square root of both sides. I'm going to write down the d first, okay? Square root of d squared is d equals, d is a second degree. So because d is second degree, I took a square root. That means my answer has to be a plus or minus. I'm going to assume they're going to, I don't know, how do they do something like this on the homework? That this wasn't on the homework at all? Okay. Yeah, I guess I could take a 2 out because the square root of 4 is 2. So 2 times the square root of a over pi. I'm going to go ahead and stop there. I could go one more step, but I'm just going to go ahead and stop right there. Is d by itself? Great. Okay. We haven't talked about rationalizing denominators or anything like that, so I'm just going to leave it at this point for right now. Part B, we're solving for t And I'm going to say, no, I'm not going to. I'm not going to do this. Think about the very first problem we did today. We had the quadratic formula, and we solved for x, right? This is basically the same concept. Okay, so I'm just going to go ahead and we're not going to do B. The discriminant, we'll talk about this. Okay, I've already told you that the discriminant is b squared minus 4ac. And this table here tells you what the discriminant tells us. If the discriminant is a positive perfect square, we will have two rational solutions. If the discriminant is positive but not a perfect square, we will have two irrational solutions. If the discriminant is positive, it's also a real answer. If the discriminant is 0, we will have one real rational root, but it's going to be a double root. Because remember, it's a quadratic, there has to be two answers. So if the discriminant is positive or 0, we're going to have real answers. If the discriminant is negative, we'll have complex answers. And there's going to be two of them, two imaginary solutions. Do y'all remember talking about this last semester? Okay. Okay. I'm going to go ahead and stop there. I'm going to take about 3 minutes tomorrow. We're going to solve for about 3 discriminants, and then we'll be totally done.